Thanks for coming. Believe it or not, Spotify is, people call Shopify Spotify a lot, yeah. So yeah, my name is Leila. I work at Shopify as an infrastructure engineer. I'm on a team of 8 engineers called the Search Platform who develop and maintain the infrastructure that powers search at Shopify. Today I'll be talking about migrating a large-scale search data set under production in a highly available manner. In the next 20 minutes, we'll learn how the search platform team at Shopify hosts the search infrastructure on top of Kubernetes. We'll talk about the entire data pipeline that writes data from SQL to Elasticsearch through Kafka, and I will talk about the data migration process at Shopify and the challenges that the search platform team faced migrating search data, and we'll share how we address those challenges. And we will conclude the presentation with a Q&A. Introducing Shopify, for those who don't know about us, Shopify is a cloud-based commerce platform that lets you start and manage a business by allowing you to create and customize an online store and manage inventory, payments, and etc. Currently, we have over 3 million businesses using our platform. We have merchants like Gymshark and Fashion Nova selling their products with us. We represent over 170 countries around the world and have about 10% of total US commerce, and have had above $400 billion in global commerce activity. One of the largest events in commerce, especially in North America, is the Black Friday Cyber Monday week. We call it BFCM. To share more stats about the scale of Shopify during the BFCM of 2023, which was a few months ago, Shopify processed 145 billion requests in a day, peaking around 60 million requests per minute, which led to a total of $4 billion in GMV. Search is a fundamental part of any commerce platform, allowing buyers to search and filter for products, and also merchants to fulfill orders and manage their customers. When you go to any online store and search for a product, your request goes to a search engine that's backed by a secondary data store, which is different from traditional databases, and we call this secondary data store the search infrastructure. In the next couple of slides, I'm going to give a quick refresher on the 2 key technologies we'll be talking about throughout this talk. The first one is Elasticsearch. It is a distributed text search and analytics engine built on top of Lucene that has full text search capabilities that are well suited to the e-commerce domain. It's also a scalable and fault-tolerant system. It handles a lot of the hard parts of running a distributed system very well. The second technology is Kafka. It is an open source distributed streaming platform that is used for building real-time data pipelines and streaming applications. It is designed to handle large volumes of data in real time and provides a scalable, fault-tolerant architecture for processing and storing data. It is commonly used for use cases such as log aggregation, real-time analytics, and event-driven architectures. Kafka is built around the concept of topics, which are streams of data that can be partitioned and replicated across multiple nodes in a Kafka cluster. Producers can write data to a topic, and consumers can read data from a topic in real time. At Shopify, Kafka is our main messaging service. So when we build applications that need to pass large volumes of data to each other, we use Kafka. So in our use case, on our team, we rely on Kafka to receive Elasticsearch documents that are built from SQL records, and then we consume them and store them in Elasticsearch. Shopify is a large and complex technical ecosystem. It's made up of a variety of apps and services, and the biggest service at Shopify is called Shopify Core. It is a big Rails monolith that powers all of our shops, merchant shops, and storefronts. We run Shopify in GCP regions for resiliency. What you're looking at here is a high-level view to the structure of Shopify Core in a single region. Entire Shopify Core is broken down into above 100 logical groups of SQL databases and instances of other services that are required to run Shopify. These groups power all of our online store functionality for the shops that run in a GCP region. We also run one instance of Elasticsearch for Shopify Core that provides search functionality for all the shops that run in that region. And to provide more details, we have an ingest pipeline in each region that consists of Kafka topics, as we talked about, and Kafka consumers. We produce records from all SQL instances in the region to our Kafka topics, and our consumers pick up those messages from the topic and write them to the right Elasticsearch index in real time. And for simplicity from now on, I will refer to all those groups of services as Shopify Core. Taking a closer look at an example GCP region where Shopify Core and its Elasticsearch cluster runs, we have the ingest pipeline updating Elasticsearch when changes are made to SQL records. We can see here that search queries are sent to the Elasticsearch cluster through a routing layer, meaning that queries made to shops in a certain region are routed to the Elasticsearch in the same region. We know that the first step towards high availability is redundancy, and to mitigate regional failures, we should replicate our system to another region. The active SQL instances and Kafka topics in different regions hold different data sets, and we need to replicate their data between regions so both Elasticsearch clusters have the same data set. With this inter-region data replication, if one of the Elasticsearch clusters goes down, we can fail over the query traffic to the Elasticsearch cluster that is functional until the other one has recovered. To give more context, Elasticsearch is used as a secondary data store. It's utilized to provide additional functionalities such as search, fast search capabilities, aggregations, or full text search on top of the existing data set in the primary data store. Indexing is a term we will use a lot in this talk. It's the act of writing documents from the primary data store to Elasticsearch. And we saw the ingest pipeline in the previous slide that brought data from SQL as the primary data store to Elasticsearch through Kafka. In our team, we have built two different indexing pipelines for two different write profiles. One of them is called the real-time pipeline, which, for example, indexes a product to Elasticsearch and makes it available for search for buyers when a merchant creates a new product that they want to sell. The other pipeline is called the reindex pipeline. Well, we have a lot of developers at Shopify. They create indices, modify index analyzers, add or remove fields to these Elasticsearch indices. And when that happens, we need to migrate all that data to a new version of the index and promote that index to make the new feature available to buyers and the merchants. We call this reindexing, which means building an entire Elasticsearch index from SQL. To share some stats, the indexing rate for our real-time pipeline can peak at 90,000 documents per second, and for the reindex pipeline, it can peak at 500,000 documents per second. And as of today, search platform at Shopify manages above 100 distinct Elasticsearch clusters, some of which are as large as 260 node clusters, like the Shopify Core that I mentioned before, and many are as small as 3-node cluster that provide search capabilities for other services at Shopify. And together, they store more than 3 petabytes of data. One instance of Shopify core Elasticsearch has around 400 billion documents using 400 or more terabytes of storage. Our merchants and buyers are spread across the globe today, and we represent about 170 countries. Before COVID, Shopify only ran in 2 GCP regions. In the US, which were the pair that served online store functionalities for all merchants and buyers. After COVID, many businesses went online and a lot of sales became online as well. This led to an increase in the number of merchants and buyers across the globe, and latency and data locality and compliance with different geographical jurisdictions became constraints. Therefore, Shopify decided to expand to other regions of the world, and the first destination that was chosen was Europe. Now let's take a high-level look at how Shopify moved its data from the US to Europe. As you can see, initially we had 2 regions in the US where all merchants' data lived. You can see the indexing pipeline we talked about. And note that the active SQL instances shown here host different data sets, but the Elasticsearch instances host the same data set since they are replicated across regions. So the first step towards the migration was standing up Shopify and search infrastructure in the new Europe regions. Then in the US region, our database platform team made new SQL instances containing only European merchants' data, and then moved those SQL instances over to Europe regions. Everything concerning the European merchants, including the real-time indexing rights to Elasticsearch, was handled in Europe after the SQL instances were moved there. However, as you can see, the moved merchants to Europe only had access to their search data that was written after the DB migration. And they had lost access to their historical data that was previously stored in the Elasticsearch clusters in the US. Another mechanism that moves data between regions at Shopify is called a shop move, which can happen without any prior notification. It can happen anytime, even when there is no database migration planned. In this process, the entire data for a single shop is copied over to a new region. Shop moves can happen between any 2 regions. So if the source and destination regions are within a region pair, the shop move will be transparent to search as we are already replicating data between them. However, if the source and destination regions are in separate region pairs, we will run into the same problem of missing access to historical search data after the shop is served out of a new region, because the Elasticsearch in the destination region does not have the same data set as the Elasticsearch in the source region. To address the problem stated in the previous slides, we considered a few solutions. The first solution to have historical data for merchants migrated to Europe was to restore the data from a US snapshot in the Europe after the migration. Once the restore is finished, the merchants in the Europe will have access to all their search data set, and recall that they started capturing real-time updates in their Elasticsearch cluster when the migration was done, and our snapshot restore gave them the historical data as well. Let's compare the pros and cons of this solution. The pro is that this solution was simple and required no extra implementation. We just had to take a snapshot of the US Elasticsearch and restore it in the Europe region. Elasticsearch already provides that functionality, and it was easy to do. The cons, however, were considerable. We saw earlier that the amount of data that Elasticsearch for Shopify core stores is in the scale of hundreds of terabytes. Restoring that much data takes hours, during which the merchants will not be able to fulfill their orders. And also, even if we accept the search downtime during the snapshot restore, we still haven't solved the problem of search downtime after the individual shop moves. And therefore, this solution was rejected. The other solution we considered was restoring historical data in Europe from a US snapshot before the database migration. This way, when we migrate the database and the real-time rights start going into the Europe Elasticsearch, merchants already have their historical data present in there. However, they have lost the real-time updates to their Elasticsearch during the migration, and their search data set will be stale. You should know that the DB migrations were not fast operations. They often had to be retried, meaning that the time range where Europe Elasticsearch would be missing real-time updates was not foreseeable. So let's compare again. Same as the previous solution, the operation was simple, although not as simple as before, because we still needed to identify the times where real-time rights were missing from Europe Elasticsearch and had to import all rights during that time to Elasticsearch cluster. The cons were still considerable. We did see that this solution will lead to real-time updates loss that happened during the database migration. Same as before, we'll still encounter search downtime for individual shop moves. And therefore, this solution was also rejected. The third solution was enabling cross-jurisdictional rights between the US and Europe. In this solution, once we have the search infrastructure ready in Europe, and before migrating the database from US to Europe, we enable real-time rights to go from US to Europe. In other words, the rights originating from one US region will go to both US regions as well as both Europe regions. In the next step, we perform a snapshot restore and bring the historical data to the Europe as well. At this point, all 4 Elasticsearch clusters have the exact same data set. Then the DB migration happens, and real-time rights for Europe merchants will move to Europe. And since we know that it is possible for Europe merchants to move to US as well, because the shop moves are bidirectional, we also write Europe real-time updates to US, and this way we keep all 4 regions to have the same search data set. The pros for this solution are avoiding revenue loss to search downtime and decoupling from other stateful systems migration plans. The cons that are kind of obvious are that we are paying extra for infrastructure, and the cross-jurisdictional replication is complex to maintain. However, since Shopify's goal is making commerce better for everyone, and merchants should always come first, we accepted to temporarily pay those penalties and go with this solution. What you see in this slide is a temporary topology that we maintained for a while to avoid search downtime for individual shop moves. In our next effort, we implemented automated shop backfills, so when shops move between jurisdictions, their search data is automatically backfilled. And after we implemented this automated shop backfills, we disabled cross-jurisdictional rights and resized our infrastructure, deleted unnecessary data to avoid unnecessary costs. And today, Shopify, including Shopify Core, runs from North America to Europe to Australia and Singapore. Thank you, and if you have any questions, I'd be happy to answer them.